what we're seeing is there's a lot more new players to the industry. There are new applications ranging from biodiesel production, wastewater treatment, to using methanol as a hydrogen carrier for fuel cells, and using methanol as a transportation fuel in cars, trucks, and buses. So every time you introduce a new user or a new producer or distributor, they have to be educated. They need to know about the risks of working with methanol and how to mitigate against those risks.
Methanol is used worldwide as an effective chemical commodity and fuel. This video is an information resource for methanol and has been developed to promote the safe handling of methanol and minimization of health risks to employees, workplaces, the environment, and the community. It is a companion to the more comprehensive printed Methanol Safe Handling Manual, freely available at methanol.org. The key points we will cover in this video are the basic physical properties of methanol, the key risks associated with handling methanol, ways to minimize methanol exposure, fire, or release into the environment, and what to do in case of an event involving methanol. Let's start with the basics. What is methanol?
Methanol is a basic chemical. It is used in the production of a whole range of materials.
Also known as methyl or wood alcohol, methanol can be found in everything from windshield washer fluid to fuel cells.
Methanol finds its way into literally thousands of different products: adhesives, paints, plywood, plastics.
It's also used as an alternative fuel, as an additive in gasoline to reduce harmful emissions. It's used on its own as a racing fuel, very high octane, high performance, much safer than gasoline.
Methanol is a colorless, organic liquid at room temperature and pressure. Let's look at methanol's basic physical properties. 1. Methanol is an easily ignited hydrocarbon that burns in air. 2. Methanol vapor is heavier than air. As a result, if there is a release, methanol vapor may collect in confined spaces and low-lying areas. 3. In certain circumstances, methanol vapor explodes on ignition. 4. Methanol is a toxin. Ingestion can cause death. 5. Methanol is totally water-soluble. Let's look at the fire hazards of methanol. Methanol is extremely flammable and releases extremely flammable vapors at ambient temperatures, and when mixed with air, it can burn in the open.
The unique characteristic of methanol is that when it burns, you don't actually see the flame typically, especially if you're looking at it into the sunlight or a bright light. Sometimes you may see a shimmering like you would see on asphalt on a hot day, but you may not necessarily see a flame.
During our drill, the fire department people walked up just to see what was going on. And they said, the fire department's approaching very slow. What's wrong? Why don't they get in there and really get involved in firefighting? Well, the fire department had some infrared devices that they were actually simulating looking at a fire as they approached.
Using common sense safety practices, eliminating potential ignition sources is critical, like smoking, running vehicle engines, not using sparking tools.
Hot work is the #1 cause of death related to methanol handling. For example, welding, brazing, soldering, cutting, heat treating, grinding, or using power-actuated tools.
In the biodiesel industry, hot work is the #1 safety concern that we have. We've actually had loss of life because of hot work being done on a storage tank or a methanol tank where a spark or flame has caused an explosion.
In 2006, an incident occurred when workers at a Florida wastewater treatment plant used an acetylene torch to cut a roof off a methanol storage tank. An explosion resulted, which claimed the lives of 2 workers and seriously injured a third.
Some of the lessons learned from our investigation at the Bethune Point wastewater treatment plant in Florida were that workers need to be trained in the hazards and understand the hazards of the materials they're dealing with, as well as they need to have effective hot work programs to control ignition sources when working around flammable materials.
The Fire Tetrahedron.
The traditional fire triangle consisted of 3 elements: heat, fuel, and oxygen. The concept being you take any one of those away and the fire would go out. What scientists determine is that there actually is a 4th element in that combustion chain, and that's what we call the chemical chain reaction. So now, instead of calling it a fire triangle, we call it a fire tetrahedron. And that is how chemical extinguishers effectively deal with fires, because it interrupts that chemical chain reaction. And in methanol fires involving what we call pressure fires or three-dimensional fires, using a combination of water, foam, and the chemical extinguisher will put those fires out effectively.
Basic safety measures. Methanol is toxic. Do not eat it, drink it, breathe it, or stand over it. Routes of exposure to methanol: breathing it in, skin contact, eye contact, and swallowing. Avoid breathing methanol vapors. If someone inhales methanol vapors, move the person to fresh air, assist breathing if necessary, and seek medical attention immediately. Symptoms of inhalation include irritation of respiratory tract, headaches, sleepiness, nausea, confusion, and loss of consciousness. Avoid getting methanol in your eyes. If you splash methanol in your eyes, flush with gently running water for at least 15 minutes. Lift the upper and lower lids during the flushing to ensure all accessible tissue of the eyes and the lids are flushed out, and seek medical attention. Do not get methanol on your skin. If you do, remove any contaminated clothing, wash the exposed skin with copious amounts of soap and water, and seek medical attention if irritation or symptoms of toxicity develop. Never ingest methanol.
Because it's an alcohol, people will tend sometimes to believe it's no different than any other alcohol that might be potable, but it's not.
Methanol is particularly toxic when it's been ingested. As little as 1/4 cup of methanol can prove to be fatal.
Lesser amounts are known to cause irreversible blindness. If you suspect someone has ingested methanol, do not induce vomiting. Seek medical attention immediately. The symptoms of methanol poisoning may take up to 24 hours to appear and include weakness, dizziness, nausea, vomiting, dimness of vision, and loss of consciousness. Storage and transportation of methanol.
There are different methanol safety procedures depending on how it's being stored or distributed, whether it's on a ship or it's in a storage tank on land. There are also different procedures for moving methanol, whether it's in a rail car or a tank truck or even a 350-gallon tote, 55-gallon drum, or as small as a 5-gallon pail.
Totes and drums are more subject to spills than dedicated methanol storage facilities and make up the majority of methanol storage. The following provisions are suggested for tote, drum, and pail users. Methanol should only be bought from reputable dealers. Store methanol in a dedicated area that is specifically marked. Use positive materials identification for all gaskets, filters, hose material, etc. Ensure procedures are in place to ground containers and periodically verify grounding. Also, ensure procedures and equipment are in place for personnel protection, leak detection, alarm systems, and on-site emergency response.
We have a vapor recovery one for the unloading process when the truck comes in. Truck is also properly grounded. There's a connection where the truck will ground.
When transferring methanol, the source it is being transferred from into the tote or drum should be grounded together by grounded straps equipped with carbide-tipped clamps. Anything coming in contact with the methanol should be grounded. Electronic devices, including cell phones and laptops, should not be used within 20 feet of the storage facility. Personal protective equipment.
The use of PPE is absolutely a cultural event. People use PPE because, one, they understand that it will allow them to go home safe at the end of the day and prevent an injury. They also recognize that by wearing PPE, they're not only protecting themselves, but they're protecting the workers that are working next to them or behind them.
The appropriate level of personal protective equipment should be used based on the level of risk of exposure to methanol. At a minimum, safety glasses with side shields or safety goggles and task-appropriate gloves and boot coverage are recommended. Depending on the risk of vapor and high-volume splash, additional PPE may include a full chemical suit, chemical-resistant rubber gloves, and supplied air respiratory protection. Exposure monitoring. Methanol vapor concentrations can be measured using direct reading gas detection tubes, such as colorimetric detection tubes, or with electronic instruments, such as portable gas monitors. Gas monitors can provide continuous readings of methanol concentrations, and alarms can also be set at specified concentrations. Emergency response. The following are steps to take if a spill occurs. Reduce the release of material, if safe to do so. Evacuate all persons not wearing protective equipment from the spill area. Notify the supervisor or emergency coordinator of the spill. Eliminate sources of ignition, whether an acetylene torch or electrical sparking. Don't walk through the methanol and avoid skin contact or breathing in the methanol. Stay upwind of the methanol vapors and keep out of low-lying areas. For large spills and fires, call your fire department immediately.
If you're a new biodiesel producer or a wastewater treatment plant operator, the first thing you want to do before you bring any methanol on site is to bring your first responders on site.
The key is for the local emergency responders to be familiar with that facility at the onset.
We regularly run drills. We usually will develop a mock scenario. It could be a methanol spill or a methanol fire, and we will include local officials, fire departments, so that we have a good understanding that in the event one day we have a real incident, we can be very effective.
The following emergency equipment is needed on site. Fire extinguishers, including CO2 extinguishers and dry chemical extinguishers. An industrial first aid kit. Portable eye wash station that can give 15 minutes of water. An ample supply of drinking water. Emergency communication devices, mobile phones, or two-way radios that are explosion-proof. A vehicle suited for emergency transport. Release containment.
Methanol will dissolve completely in water. So if you had a spill of methanol to a body of water, the methanol will quickly dilute to levels where it's not going to be harmful to the marine environment. If the Exxon Valdez had been filled with methanol instead of oil, instead of polluting 1,400 miles of coastline, you would go back to that site 2 days later and not find a trace of methanol.
Methanol spills should be kept from entering sewers and drains by surrounding the liquid with mechanical or chemical barriers. Small spills can be contained with cat litter. A key component of emergency response planning is to conduct an incident investigation to identify the causes of the release and correct any deficiencies in process safety systems and operating procedures, as well as improve on the response effort itself.
Methanol is something that we need to respect. You should learn all the safety aspects, health components of the methanol, the firefighting requirements, and make sure that the system is designed in a proper way.
We need to make sure that everybody understands that this is a very useful, very beneficial chemical, but it's toxic and it needs to be handled carefully.
For more information, please visit the Methanol Institute at methanol.org.